Okay, now for the guided practice. The first few problems are just, can you run computations on the calculator? Just getting you used to computing these. They should be easy. You shouldn't miss them. As long as you know how to do them on the calculator, you should be good. Number 1, 6 factorial. Let's do that on the calculator. Remember, there's 2 ways. You can go 6, menu, probability, and factorial. Get your answer, which is 720. Or you can do 6 and get your exclamation point that way. Again, 720. So 2 different ways, still the same result. The answer is 720. Number 2, 7 factorial divided by 3 factorial. Again, we can do this on the calculator. 7, I'm going to do the quicker way because I like it better. 7 factorial divided by 3 factorial. So that answer is 840. 840 is what you'd get when you do 7 factorial divided by 3 factorial. Now, for number 3, there's tons of different ways you could do this one. You could type it in like it is. 8 factorial divided by, in parentheses, 8 minus 3 factorial. Or you could say, wait a minute, I know 8 minus 3 is 5. So this turns into 8 factorial divided by 5 factorial. You could type it that way. Another way you could do it is say, oh, this is NPR. I want to use that fancy trick on the calculator. So you could say NPR and do 8, 3. That works also. No matter the way you pick, you'll get the same answer. I'm going to do the NPR. So menu, probability, permutation. And then we'll do 8, 3. You get 336. 336. Regardless of which way you pick, you'll get the same answer. Okay, number 4. How many 5-digit ID numbers are possible if all 10 digits may be used? So we can pick from all 10 normal numbers, and digits may be repeated. Okay, so how many digits are in our ID number? There's 5, so let's draw 5 blanks. 1, 2, 3, 4, 5. Now, we're just using the 10 normal counting digits. So 10 for the first option. Now, they tell us we can repeat digits. So we can have an ID number that's 66666 if we wanted to. So there's 10 for the first, 10 options for the first digit, 10 options for the second digit, 10 for the third, 10 for the fourth, and 10 for the fifth. You just multiply all of these together. 10 times 10 times 10 times 10 times 10. And that would get you 100,000 ID numbers. So you could have 100,000 possible ID numbers. But now let's see what happens if you can't repeat digits. So we're still dealing with a 5-digit ID number, but now it tells us digits cannot be repeated. So there's still 5 digits that we have to have in our ID. But now we have 10 options for the second. 10 for the first. How many left for the second if we can't repeat? 9. And then 8, then 7, and then 6. So we're counting down. Multiply all these together and you get 30,240 ID numbers. Notice how much we drop when we just slap the restriction on there that you can't repeat. We lose almost 70,000 numbers. Let's make life even more interesting. Let's say we're doing 5-digit ID numbers. So 5 blanks. 1, 2, 3, 4, 5. But this time, they tell us an ID must start with a non-zero digit. So that means this first one cannot be 0. So no 0 there. Well, if the first one can't be 0, how many options do I have to pick from? Just 9. I only have 9 options because 0 is not an option for the first one. But then they tell us digits may be repeated. So that means I could say all 10 are available now because I can use 0 this time. For the second digit, I can use 0. I can use it for the third, fourth, and fifth. So the only thing they changed was that it can't start with a 0. So do 9 times 10 times 10 times 10 times 10. That gets us 90,000 ID numbers. Okay, so there's number 6. Number 7, this is probably some of y'all. Max forgot to study for a 10-question true-false quiz on Friday. He wants to determine the probability of making a perfect score if he just randomly guesses true or false on each question. How many different ways can he answer the quiz? And what's the probability he makes a perfect score? Well, what do y'all call a perfect score? If you're taking a test, what do you call a perfect score? 100, right? So he wants to just answer randomly and see what the chances are that he can get 100. Just true, true, false, false, whatever. I'm just going to guess all the way down. Honestly, on some of y'all's tests, I think y'all do the same thing. But nonetheless, let's see. So for the first question, how many options, or for all the questions, if your answer choices are true or false, how many options does that give you? That only gives you 2 options on each question, true or false. So there's 10 questions here. I'm not going to draw a blank for all 10 because that would cover my whole page. So that blank's for number 1. How many options does he have for number 1? 2, true or false. What about question number 2? How many options? 2, true or false. What about question number 3? How many options? 2, true or false. And that just keeps going all the way until he gets to question number 10. So on number 10, how many options? 2, true or false. So we're going to multiply 2 times 2 times 2 times, we're going to do that 10 times, which gives us 2 to the 10th power, which is 1,024 ways. That's how many ways he can answer his test. Ways to answer. That's the first part of the question. It asks how many different ways can he answer. That's how many different ways. 2 to the 10th. Now, how many ways can you make 100 on a paper? Perfect score means he makes 100. How many ways can you make a 100 on a paper? There's only one way to do that. You get all the right answers. Let me back up. There's only one legal way to do that. Get all the right answers. We're not going to talk about passing money under the table or anything like that. There's only one legal way to get it. You get all the right answers. So the probability that he guesses on all 10 questions and makes 100 is 1 out of 1,024. Which means as a decimal, that's 0.000977. Or if you want to know your percent chance, he's got a 0.0977% chance of making 100. It probably ain't gonna happen. He should have studied. That's why when y'all turn something in, especially on the multiple choice, it's like just take a shot at it. If you leave it blank, you're probably going to get it wrong. If you don't know it, you're probably going to get it wrong, but at least you still got a chance. If you turn in a blank test, you have no chance. But he's got a slim chance, even though he didn't study, he doesn't know what the heck's going on. There's still the chance. Okay, number 8. Which state name has the most rearrangements of the letters in its name? Florida or Tennessee? Well, let's look. So first we're going to look at Florida. So how many letters are in the word Florida? There's 7. Do any of them repeat? No, we have no repeats. So that means there's 7 factorial arrangements, which gives us 5,040 ways to arrange Florida. Now let's look at Tennessee. How many letters are in the word Tennessee? There's 9. Are there any repeats of letters? Oh yeah, there's multiple E's. How many E's do we have? There's 4. How many N's do I have? There's 2. What about S's? 2 S's. So if I get the repeat, or if I want unique arrangements, let's see, that's going to be 9 factorial over 4 factorial times 2 factorial times 2 factorial. Now, in the lesson video, I went over the correct way of putting this in the calculator. I'm not going to spend time again showing y'all on the guided practice. If you didn't see how in the lesson, go back and watch it. You type all this in, you'll get 3,780 ways. So which one has more? Which one's greater, 5,000 or 3,000? Definitely the 5,000. So we can say Florida has more arrangements. Or rearrangements, I should say. Florida has more rearrangements in the name. Okay, last one, and then we're done with the gathered practice. So a bag contains 9 chips. That means there's 9 total chips. Or we can say N equals 9. 4 are red, 3 are blue, and 2 are white. How many unique permutations are possible using all 9 chips? So we're ordering them. Well, they have repeats. Each red chip looks the same. It's a red chip. So there's 4 repeats for reds. Let's make note of all this. Let's see, there's 4 reds, 2 whites, and 3 blues. Those are all repeats. So if we want unique permutations, that means we're going to have to say, well, it's going to be 9 factorial over 4 factorial times 2 factorial times 3 factorial. We have to take into account the repeats. We type all this in the calculator, unique ways, that gives us 1,260 unique ways. Okay, so that's it for the guided practice. For the assignment, the questions are pretty similar to what we've been doing. I mean, the first 3 on the practice problems, just typing it in. Then you got some ID type questions. 17 and 18 are just like we did on the true false, except he has 20 multiple choice where you can answer A, B, C, or D. That's the only difference between that, the true false, and this one. That's it. How many ways? What's the probability she gets a perfect score? Pretty straightforward. So, and then the last one, number 21 is like the exam number 9 that we just did. For 19 and 20, you may have to look back at your notes. It's just straight up probability. There's, 12 chips in the bag. What's probability you get a yellow? Number of yellow over the total, boom. There's your answer. So look back at the notes if you need to for those. Other than that, that's it for today. We're halfway through the unit. Let's keep it going.